All right, welcome to the Exam 3 review. So this is going to look pretty much the same as all of the other exams. So 8 true false, 8 multiple choice for problem solving questions. When I talk about conceptual on the next couple of slides, that is just the true false multiple choice part. Live Friday at noon, closes midnight on Saturday. Again, same format the rest of them have been. If we go through and look at our course competencies, we see phasors and first order circuits are things that we have now technically covered. So you will have 2 first order circuits as of where the exam is right now in the writing process. With the phasors, because we haven't done anything very exciting with them for exam purposes, they will just be in the conceptual part, but understand that they might show up for the final, but they are fair game for conceptual. So for the other sources stuff, this will be, you'll need to either calculate the dependent voltage or current source. So this will just be a resistor circuit for going through and solving that. So whatever method you like for that. These for AC sources, be able to calculate RMS, average, and peak values. Phasors, again, for now, just the conceptual part. So be able to go through and match the phasor for a wave, that type of thing is expected of you. Phase shift, so that is going to be how far off we are from sine. Also fair game for conceptual. Unimportant for the other types of waveforms. We know they exist, but we are just doing a sinusoidal AC source. Chapter 12 was our capacitor chapter. So be able to go through, calculate series and parallel capacitance. So identify the charging versus discharging ways to use the equation. So if you look right now, the equation sheet is also, as of where it stands right now, I'm probably going to go back and add the resistor stuff. But right, that's there. Actually, the resistor stuff's on there by the time you're seeing this. But anyway, right, being able to go through, look at charging versus discharging. So being able to calculate tau and things like that. So DC and or AC. With reactance, this is something that will probably show up in the conceptual portion of the exam, but I put it in the study part just because it's technically fair game. But if it's in problem solving, it's going to be a relatively simple one where maybe you find the total capacitance for a circuit and then find the total reactance, which is right using that reactance equation. But calculating capacitance, so that's using the C is equal to epsilon naught A over D, A over D. That equation, conceptual only, the idea of leakage, conceptual only as well. And again, we're not going to care about energy. Chapter 13, so as of recording this, we have not done the AC and DC circuit stuff. We are covering that on Tuesday. That is fair game for this exam. But be able to go through, calculate inductance in series and parallel. Be able to take the time derivative of a sine and or cosine function. Reactance, again, will be similar to with capacitors, where if it's in problem solving, it's going to kind of be a find the total reactance type thing. Conceptual only will have Lenz's law, winding resistance and capacitance, and using the inductance equation where we have the length of that wire in there. Energy is not important. The different types of inductors are not important. We're just going to go through and deal with air inductors for the entirety of the exam. So if you have any questions about the exam, please be sure to ask.